The one I just worked on is in West Texas. It was a 138 kV line that was not very old, just a couple years old, and we had a West Texas thunderstorm, which was pretty significant, but nothing close to what the line was designed for. And they had a mile of line cascade fail. So there was essentially, what that means is 13, 14 structures laying down on the ground.
And they kind of go one after another in sequence as they're failing.
That's what we needed to determine. They called EXO. Houston, we have a problem. And we have the reputation when something catastrophic happens on a high voltage line or distribution line for that matter, people know that EXO has the engineering expertise and the manufacturing background to be able to mobilize and investigate, do some forensic work, do some lab metallurgical work if that's what it takes, and the engineering and manufacturing backgrounds in-house to be able to get to a root cause of that failure. And oftentimes that leads to new provisions being proposed for our codes and standards, and at the very least, something that the utility can incorporate into their own specifications, because there are details that matter that a minimum design code standard won't address, that you as a utility will want to have in your specification.
Absolutely.
So in this case, they needed to know, why did a mile of line wind up on the ground of a 2-year-old line under an average Texas thunderstorm? So we went out there and started trying to investigate what triggered this. Was it the entire line going across like a fence that just got a straight line wind for a mile wide, and did it fall down all at the same time? Or was there something else going on? And it's not untypical to have a trigger event and then a propagating or a cascading failure of the neighboring structures, like dominoes, once one structure has failed and there's no provisions to cease or arrest that failure through the design of the adjacent structures. And that's what happened in this case. We investigated and found out that, interestingly enough, it wasn't just a ground line cross-sectional overstress. There was something up the pole where there was an overlapping slip joint, and there was some peculiarities about the design and the manufacture of that slip joint that we were able to determine that, yes, indeed, that's where the failure initiated. And then we went through other line models to determine what stresses then impacted the adjacent structures, to the point where it failed and cascaded to a point where then it hit a dead-end structure.
Yeah, and I think you hit on some real key elements there, Ken, that makes EXO pretty unique, right? It's all of this engineering and technical experience and background. We've had several of those folks on the podcast here, including yourself with all the engineering background. That's critical in this root cause analysis. But then you have this inspection component. Okay, the pole's on the ground. You know what to do with that pole. But what about the poles that are several poles beyond that? What kind of damage maybe did they see? So all of the technical expertise to go and look at those poles that are still standing, but maybe deficient in some way due to some stress. And then what do you do about it, right? It's the third piece is, now how do I go in and rectify, remediate the situation? And there's very few folks out there that can do all of that engineering and analysis, the in-field inspection, and then synthesizing all that into a remediation that ultimately is trying to give the client the best solution.
Absolutely. And that's the thing that resonates with us as a team at EXO. And what I love about working and being a part of that is to have problems, but to have the team to be able to mobilize the whole of our experience in a solution that solution is not any cost. It's with it in mind that there are replacement solutions, but if we can extend the life or restore the strength of a structure certainly catastrophic failures are one thing, and then slower attacks on the structural integrity of a structure or a series of structures is another thing. But our solutions brain trust can come to those projects wherever they are, because at EXO we've got a fleet of vehicles and tools, and most importantly, the field inspectors, the training that they've received, the credentials that they have, and the knowledge that they bring. The utilities don't have that luxury anymore. Back when I started at the utility in Austin, we had a very strong engineering department. We had our own construction crews, and we had knowledge that we could bring solutions internally, but that's very rare these days. So EXO fills this spot in the industry where we have people that have worked for the utilities, that have lived those problems and been in manufacturing and have seen where those problems maybe can start from and the pressures that cause that, even in the construction side. So it's a team effort, but to be able to deploy the field personnel and have the team at the headquarters huddling to do the appropriate decision asset by asset allows us to provide a solution no one else can.